In this video 5-6, we are going to be looking at parallel and perpendicular lines. By the end of the video and work time in class, you should be able to say, I can write equations of parallel and perpendicular lines. We'll start with parallel lines, or lines in the same plane that never intersect. Perpendicular lines are lines that intersect to form right angles. When we're looking at parallel lines, you have non-vertical lines are parallel if they have the same slope and a different y-intercept. Vertical lines are parallel if they have different x-intercepts. So the key here is they have the same slope with different y-intercepts, unless if they are vertical lines, two vertical lines with different x-intercepts. An example, y equals 1/2 x plus 1 and y equals 1/2 x minus 2 are parallel because they have the same slope, and you can see the same slope here is 1/2. And while they have the same slope, they have a different y-intercept, 1 and -2. So if we were to graph these two lines, we would have the first one, I will graph with blue. The y-intercept is at 1, and with a slope of 1/2, it's rise 1, run 2. The other line I will graph with a green marker, where the y-intercept is at -2 and the slope of 1/2, so rise 1, run 2. And you can see here, same slope, different y-intercepts, they are parallel. In looking at slopes of perpendicular lines, you have two non-vertical lines are perpendicular if the product of their slopes is -1. A vertical line and a horizontal line are also perpendicular. So if you don't have a vertical and a horizontal line, you want to look at that product of the slopes is -1. Another word sometimes I use here is they are opposite reciprocals. So an example here, y equals 1/2 x minus 1 and y equals -2x plus 1. If we look here at the slopes, we have 1/2 and we have -2. If you take 1/2 and -2 and you find the product, which means you multiply them, you end up with -1. You also can see here that if you had -2 as a rational number, it would be -2/1. They are opposite reciprocals. We know 1/2, the reciprocal is 2/1, and since 1/2 is positive, the opposite is -2/1. That's where you get opposite reciprocals. So if I were to graph these two lines, the first one I'll use my blue marker here. Let's see, y equals 1/2 x minus 1, so it crosses at -1. It has a slope of 1/2. And then the other line crosses at 1 and has a slope of -2, so down to right 1, down to right 1, or up to left 1. Should be down a little bit more here. And so you can see here that these lines are perpendicular. If you look right here, where they intersect, they make 90-degree angles. What is an equation in slope-intercept form of a line that passes through 2, 15 and is parallel to the graph of y equals 4x minus 1? So it said slope-intercept form. So that's y equals mx plus b, where our m is our slope and the b is the y-intercept. If it's parallel to y equals 4x minus 1, it has to have the same slope. So I'm going to erase the m, replace that with 4. So we know the m. Now we have to figure out the y-intercept. We know that this linear equation goes through the point 2, 15. So I'm going to replace the x with 2 and the y with 15. So 15 is the same as 8 plus b. So that means b is the same as 3. Oh, sorry about that, 7. So b is the same as 7. Okay. So in slope-intercept form, y equals, the slope is the same to be parallel, x, and we found out that y-intercept is 7, so plus 7 because it was a positive. And there is our equation that would be parallel to y equals 4x minus 1. You see they have the same slope, but they have different y-intercepts. Are the graphs of 2y equals negative 3x plus 6 and y equals 2/3 x plus 2 parallel, perpendicular, or neither? Now we can see right here y isn't alone. We want to get it in the slope-intercept form so we know the slope and the y-intercept. So what we're going to do is we're going to solve this for y. So if we have 2y equals negative 3x plus 6, we want to divide both sides by 2. Now the y is isolated and we're left with negative 3 halves x plus 3. And our other equation is y equals 2/3 x plus 2. So when we want to know if they're parallel, perpendicular, or neither, let's take a look at our slopes here. We definitely right away see that they're not the same. So they're not parallel lines. So we look, we have a negative 3 halves, and we have 2/3. We see they're opposite reciprocals. 3/2 flip, 2/3, and 1 is negative, the other's positive. If you were to multiply, those all simplify to 1, reduce to 1. You end up with negative 1 for your product of your slopes. They're opposite reciprocals. So they are perpendicular. So perpendicular is the answer because the product of the two slopes is negative 1. What is the equation of a line that passes through 10, 15 and is perpendicular to y equals negative 5, 6x minus 2? So we have to think, if we have negative 5, 6 for our slope, that means the opposite would be a positive, the reciprocal 6/5. So that would be the slope of our line if we needed a line that's perpendicular to the one they gave us. So we know y equals 6/5, there's our slope, x plus b. So now to figure out that b, we're going to put the point in that they're saying that this equation we're looking for goes through. The x in that point is 10, and the y, and we're multiplying here, and the y in that point, the y coordinate of that point is 15. So if we're multiplying these two rational numbers, that's one that's 2. So it's 6 times 2 is 12. So 15 is the same as 12 plus b. So that means our b is 3. So our equation is y equals, here's our slope, it's the opposite reciprocal, x plus 3, which is our y-intercept. Here we have a problem that we will be graphing. Carla's using a coordinate grid to make a map of her hometown. She plots Main Street. And so I'm going to do some labeling here. We're going to say this is 0, and then I'm going to go up, let's see, 2, 4, 6, 8, 10. And then I'm going to do the same here. On the bottom, we're going to go by the same value, 2, 4, 6, 8, 10. Okay, so each square is 1 point. I'm going to graph Main Street. So Main Street is here, and then here, and here are some lines. I'm going to connect. Oh, and that's definitely not a straight line here. I can try to make it a little better. And it's not, but you guys get the idea here. This right here needs to be a straight. For some reason, my nice smart board. Okay, so this is Main Street. And I'm trying to get the slope to be pretty obvious here. It's negative 1, 1, 2, 3, 4, 5. Negative 1, 1, 2, 3, 4, 5. So the slope here is negative 1/5. And so that's Main Street, and it says that she plots Main Street, so there it is, and 3rd Street is perpendicular to Main Street at this point. So we need a perpendicular line to Main Street at that point. So if it's perpendicular, the opposite reciprocal from negative 1/5, flip negative 1/5, you have 5 over 1, and it would be the opposite, so it would be positive. So the slope is 5 of this line that's perpendicular, and it goes through this point 5, 7. So y equals 5 times x plus b, which is the y-intercept. And so when we solve, 7 equals 25 plus b. When you subtract 25 from both sides, your b ends up being negative 18. So your equation for 3rd Street is y equals 5x minus 18. And that would be the location for 3rd Street. So can you say I can write equations of parallel and perpendicular lines? Write a summary and review and be prepared with any questions for the work time in class.